Hello everyone. In this video, we will examine the wave behavior of reflection. So reflection is formally the change in direction of a wave at an interface between different media such that the wave returns to the original media. In other words, if a wave goes somewhere, it reflects, then it comes back to where it was to begin with. We can examine this phenomenon by first looking at the case of a reflected wave pulse in a one-dimensional string. So, as this wave pulse is sent along, it has amplitude A, we want to think about how it's moving. So in particular, zoom in here a little bit, why does this part of the string end up going upwards? Well, this part of the string ends up going upwards because its neighbor pulls up on it, okay? And that happens so on and so forth as the wave pulse travels to the wall. But then finally it gets to that fixed end here where the string is attached to the wall. And just as before, this part of the wave would start to pull up on the wall. But that fixed end, that wall, doesn't move. And so when the wave pulse, all right, or more accurately, when the string right next to the wall pulls up on that fixed end, due to Newton's third law, we know that the fixed end is going to pull down on the string. And as a result, when that wave pulse reflects back, not only does it pull down on the string, but that reflected wave pulse is now inverted. That is, it has undergone a phase difference of 180 degrees, or pi. We're going to use this fact in other scenarios, in two-dimensional and three-dimensional scenarios, but it's easiest to understand in this one-dimensional scenario. Notice this is not true, if we examine these diagrams here, in the case where for some reason that end is free to move. In the one-dimensional case of a string, this is fairly unrealistic. But what would happen in theory is that as this wave pulse comes along, it would get to that free end, that end that's free to move, it would move that ring upwards, and then that ring would come back downwards and send a reflected wave pulse back into the original medium. So, given that, we can quickly examine this example. This example says to use the results about pulses reflecting from fixed and free ends to predict what will happen when a pulse in a heavy rope encounters a light rope and a pulse in a light rope encounters a heavy rope. And what we can see is we can analogize this. So think about whether the pulse in the heavy rope going to the light rope, so this is heavy and this is light, is like the fixed end or the free end, and vice versa. This one is light and heavy. And our solution is that with the light rope to the right, so in case A, the situation is similar to a pulse in a rope approaching a free end. It's easier for that pulse to move in the light rope. As a result, the reflected pulse that comes back will not be inverted. So the pulse that comes back will be upwards in the same direction as in part A. Whereas in B, as the wave pulse in the light rope reaches the medium change to the heavy rope, then the reflected wave pulse will be inverted, okay? And so you will get a wave pulse traveling in the other direction from that boundary. Notice in both cases, there will also be some of that wave pulse traveling forward, okay, continuing on.